In the same screen, we get the array layout. We also have the string sizing built in. This is just like a manufacturer string sizing tool that you would find on a manufacturer specific website. For example, in other programs, here we have Fronius's string sizing tool, and picking out our inverter and picking out our solar module will give us a variety of different options. In this example, we could have two strings of 11 or two strings of 8, and you would have to figure out in my array layout what string sizing or string configuration would make the most amount of sense. Well, in our Solar Design Tool presentation, that string sizing capability is built right into the software. And so here we've selected a solar panel and in-phase microinverters. And for this particular microinverter, it has a maximum number of modules per circuit is 17. And right here in Solar Design Tool, in the design software, we're being limited to the microinverter's capabilities, microinverters. But Solar Design Tool has a plethora of kind of final design detail documentation, more than any other, really any other software. It provides the most detailed out of the box one line diagram, which is pretty impressive given that it's kind of on the low end of price, with the caveat that its tools are really geared towards small residential projects, 4 circuits or less in general. Sometimes I'll model larger projects and then kind of stitch them together in CAD afterwards. But once the design is put together, you can go back in and modify things like wire sizes, connection versus load side connection. It's common to do either or. There's certain situations when one's better than the other. But it's nice to see that detail, whether or not there's a production meter, interconnection meter. This is a pretty detailed interview. And if you're hiring out to a third-party CAD service, if they don't have this level of detail, then they're not going to be able to give you a thorough electrical drawing. And so here we are. What it's modeling is our sub panel with the microinverters all landing on different branch circuits, and then tying into a solar production meter, going through a main disconnect breaker, and then heading out to either the utility main service panel or the utility meter, because it's been denoted as a supply side connection. So these one line diagrams do get automatically generated at some point in the chain. Where some of these line diagram creation tools fall short is the balance of system material wanting you to detail exactly what it's going to be out in the field in construction. So for instance, here's a popular rooftop transition box that's for transitioning the cable to go down into the attic, and being able to interrupt these home runs and say, no, right here, I want a junction box to transition into the interior of the attic. Sometimes that level of detail needs to be kind of re-highlighted in CAD. We are noting, based on earlier where we specified the location of the meter and the location of the sub panel, where we're specifying circuit detail, what is the conduit run going to be in, how long are those runs, what are the voltage drops of the runs. So these runs are all of equal length. You can go back and adjust that to be more accurate. At the end of the day, Solar Design Tool connects all those dots together to tell you, okay, you use this many feet of cable, this many feet of conduit, here's the voltage drop. They're actually the only, well, we'll get to that in a minute. So here's an example of a conduit schedule where, I know the print is fine, but it's telling you, you have a combination of 3/4 inch and half inch and 3/4 inch conduit. You might go back into this software and say, okay, it's all going to be in 3/4 inch. So we're going to upsize our conduit, and that'll change your conduit fill calculations, and gives you a good glance at your balance of system material as well. You might be looking at this material list and saying, well, why don't we simplify it? And sometimes you can oversimplify, like using number 8 cable for every circuit just to only have number 8 cable. That could result in you spending too much money on your cable budget. But if there is just like one oddball saying, okay, well, there's two circuits of 12 and one circuit of 10, but look, this circuit of 12 actually has, some voltage drop to it. And so let's make it a circuit of number 10 AWG instead, and for voltage drop mitigation. And then, even though this particular circuit maybe has fewer optimizers or fewer microinverters, so less current going through it, it doesn't have much voltage drop at all. But let's go ahead and make that number 10 as well, just so that these conductors are uniform. This is a one-line diagram that was created as a result of this kind of survey process, all by computers and surveys. There's no one hand drawing this. It's not like I fill out a survey and overnight the design to the designer who squirrels away overnight and he hand draws this. This is all computer generated and CAD exportable. And SolarDesignTool is the only one of the design softwares that I know of that has the balls to give you a National Electric Code report of calculation after calculation that you can just print out and staple and include with your permit package to say, hey, look, we've evaluated the design from a electrical perspective. Um, it's really trying to be a permit company. So it's a pretty good one. I think its main limitation is that it's only good for small residential. It does not have the capability of doing commercial, and even some large residential might run into problems with it.